Okay, this example is referring to the connected tour. So suppose we want to start from one given point. Let's assume its starting point is point 1, and we want to find out how we can travel to different nodes and come back to the same node without creating a loop or passing any of these nodes more than one time. Okay. Now, in order to model that, again, I put a virtual demand on each node, and I put a generation here as well, and then try to supply every demand in the system. And the objective function is defined as the UI multiplied by dij. uij multiplied by dij. uij are the binary variables, and the flow will determine from how the production is flowing to the demand points. And also the flow should be less than ui multiplied by a big M. In order to make a connected tour, it means that at each node, let's call it I, there is only one flow going out. And also at each node I, there's only one flow is coming in. Okay, so in this way we can make sure that we have a connected tour. Okay, so let's have a look at the code. We import the required packages, and also we go forward. So you can see here that the model abstract is created, and also we do need to specify the number of nodes. Set I is representing each node, and j is the alias of I. U is a binary variable defined over set I and j. Flow is a real variable. It's always good to specify the bounds for your variable, so I can put a bound for your variable, and I tell Pyomo that it's a non-negative real number, it's a positive one, and variable g is also between 0 and model n, and also the objective function is non-negative real, so we can initialize any variable as well. And also the locations of these nodes are randomly allocated. The second rule is calculating the distances between different nodes for each pair of nodes, and a parameter is defined for that. And also the nodal balance is defined here. For only node 1 it has a G, but the rest of them are only pure lows. The next rule is telling us flow is less than u multiplied by a big number. I chose that big number equal to number of nodes. So this constraint is defined over I and j. Okay. It's definitely better if we define this rule in a way that it doesn't it's not calculated for the cases where I and j are equal to each other. So let me modify this code for you. Okay, so I put a if here. Okay, so here you can see that if I is not equal to j, then return this. Okay, else return what? I have to skip that constraint in case that these two are equal to each other. So constraint dot skip. Okay, I hope it's correct. Okay, so I will check it for you next, and then let's have a look at the other code, the other constraint. This constraint is telling us that summation of uij over j should be 1. It means that the outgoing edges should be only 1. And also this one is telling Pyomo to say the incoming edge to each node should be only 1. And the objective function is doing the summation over urc multiplied by drc and so on. Okay, so let me run the code. Okay, and this one, okay, it is also correct, and the solver is chosen. I run the it says constraint has no skip. Maybe I have made a mistake the way I wrote the skip. Skip should be capital, I think. How about now? So I run it again and check the result. So I'm waiting for the model to give me the solution. Okay, so here you can see we have a connected 2. Okay, so as you can see, all the nodes are connected to each other and the degree of each node is 2. So you could write it down in a different way. So instead of writing it as 2 separate constraints like model.c3 and c4, you could say degree of each node should be exactly equal to 2. That should give you the same kind of result. Thank you very much.